Hello, everyone. My name is Isela Warner from the Gurobi marketing team. Thank you for joining us for this hour-long webinar, Add Decision Making to Your Databricks Toolkit with Mathematical Optimization. There will be time reserved at the end to answer questions, but please feel free to submit your questions using the Q&A feature. If we can't respond to your questions directly, we'll make sure to respond to you individually shortly after. Today, you will be hearing from Dr. Yash Puranik, Principal Data Scientist at Aimpoint Digital. Yash brings over 10 years of experience in addressing clients' optimization challenges across a multitude of diverse industries. Honored as a Data IQ Neuron and holding advanced certifications in Alteryx and Databricks, Yash is skilled in the implementation of optimization solutions across various enterprise platforms while ensuring their sustained mentoring and maintenance. Yash obtained his PhD from Carnegie Mellon University. We also have Jerry Yurchison, data science strategist at Gurobi Optimization. Jerry has over a decade of experience in operations research, data science, and visualization, and specializes in enhancing decision-making with data. Before joining Gurobi, Jerry worked in consulting with On Location and Booz Allen Hamilton, supporting numerous projects by building and customizing mathematical optimization models and leveraging machine learning, applied statistics, and simulation, all to support decision-making through data-driven narratives. Jerry also has a background in college-level mathematics instruction and has experience in career management from his time at Booz Allen Hamilton. Now at Gurobi, he aims to promote the integration of mathematical optimization into the data science and broader AI communities. So without further ado, I'll turn it over to Jerry. Jerry?
Thanks for that wonderful introduction, Isela. Again, I'm Jerry Yurchison at Gurobi, and let's get rolling. So let's start with talking about some of the topics that we're going to cover in this webinar today. So what you're going to learn from myself and Yash is we're going to go through an introduction of mathematical optimization, sort of talk about what it is and where it's used, the problems that it solves. And then going to also talk about the power of Databricks. Many of you may be very well aware of this, but how it's has great integration with machine learning and how all of that sets a great foundation for optimization. Yash is going to go through a really interesting use case that shows the synergy of mathematical optimization and machine learning. I'm going to talk about a couple of key important notes about using Gurobi in Databricks, and then also talk about some resources that you can dive into right away to help you understand mathematical optimization. Here is our intro to mathematical optimization. And what I want to first talk about is, okay, who's using this? Where is it being used? And sort of why is this an important tool for you to be able to help drive decision making? This is a sort of small sample of the customers that use Gurobi specifically. We've worked with over 2,600 companies across over 40 industries. Optimization is actually everywhere, even though you might not see it. And what kinds of problems does it solve? Well, it solves a lot of problems, a lot of different types of problems. One that we like to highlight is the NFL uses Gurobi to actually help understand its or to help derive its schedule each year. It's a very complex problem, very nasty problem to solve, but Gurobi's there behind the scenes to help that happen. And a couple other case studies that we have to offer that sort of show the synergy again between mathematical optimization and machine learning. A couple I've shown right here. So in short, the main message is optimization really is in a lot of places. You just might not see it. Next thing I want to mention is how does optimization sort of fit into the sort of broader AI sort of spectrum? And what you sort of see right now is typically when you see AI or you hear AI, and then you sort of think, okay, well, let's talk about predictive analytics or machine learning. This is sort of what you see here. You see things like deep learning, classical machine learning, and things like that, where you have some data and you want to solve a problem. But in many cases, you see at the bottom of what you see on the graphic on the left, you see, is the goal achieved? Well, typically the goal isn't achieved just through these these modeling types or these processes. Typically, the end of a machine learning project is to help drive decision making or to help inform a decision. So everything that's sort of up on the top, that's where predictive analytics lives. But again, if you're trying to help out with decision making, then that's not all, that's not necessarily always in here. And so as I reveal the rest of this awesome graphic, there's a lot here, but I sort of just want to mention that the bottom part is sort of highlighted in red is a little bit more where the decision making happens. And you can see, you sort of follow through this a little bit, you eventually get to find optimal solutions with constraints, and that is mathematical optimization. So the key point I want to have here is that mathematical optimization does fit in, it is part of the broader AI sort of skill set and tool set that you can use to help with decision making. So now that we know that people use mathematical optimization, that it's part of like this broader AI toolkit that you should have sort of ready for yourself and your team, when is it the right tool? Well, let's talk about some of the key characteristics of mathematical optimization so you can then understand when these problems sort of pop up for you. So mathematical optimization it's an approach that you use to solve very complex decision problems where you want to find the best course of action. So one way that I like to think about machine learning and optimization sort of coexisting together is machine learning provides a lot of the thinking, but optimization provides the action, the decision, what to do. So when you want to find the best course of action among many possibilities that the decision maker can set, so you actually have control over these decisions. You can set the number of sort of trucks you want to use for shipping or something like that. But there are specified limitations, so you have some constraints over your possibilities. So you can't send 500 trucks out for delivery when you only have, let's say, 50 or 100. There's some particular objective in mind, so you would like to maybe minimize your costs or maximize efficiency. Those are the key characteristics of a mathematical optimization problem. And essentially when you want to sort of go through this process of modeling, you take the decision problem that's sort of described as in words or in language that I just sort of went through a little bit, and then you got to do a little bit of fun math. Well, I guess you don't technically have to, but you really should, because it really helps streamline the process. But all of those things that I just highlighted on the left pop up in the algebraic representation of these business problems that you sort of see on the right. So we have decision variables. Those are the decisions that decision maker can set, and they come in a few flavors. They can be continuous variables, so it could be any number, sort of greater than or equal to 0. They come in binary, things are 0, 1, sort of on-off switches, and then they also come in integer flavors as well. So if you're doing something like making an airplane, making half of an airplane isn't really feasible, so you want to make sure that you have sort of an integer there. Next is constraints. Sort of see that in the algebra model there on the right as well. Those are your limitations, your budgets, your people hour restrictions, things like that. And then we have an objective function where all of this sort of comes together, where you have your minimized costs, you maximize your revenue, things like that. So you have that algebraic representation, and then you add in the Gurobi solver to help sort of find that optimal solution for you. So there are essentially 3 ways that you can combine machine learning and optimization. And the first is actually, it's a little sneaky maybe, but if you think about what machine learning algorithms actually are, is they are optimization problems in a sense. They are minimizing some loss function or some cost function, something along those lines. You're trying to get the best fit. So optimization is actually under the hood of many of these machine learning algorithms. So it's an interesting sort of relationship that we have there. And actually mathematical optimization can work very well for some machine learning algorithms. And actually we have a couple examples on our website. I'll hint to these a little bit later or tell you where to find them, where we talk about doing regression with instead of least squares regression, you're doing least absolute value. Your error function is not the squared sum of squared errors, but it's the sum of the absolute errors. And that's something that's a little bit different to handle. So we have an optimization problem for that. And then also best subset regression is a mixed integer program there. So it's an interesting relationship that we have there. The most common way that you sort of see optimization and machine learning working together is you have a machine learning model that provides some numerical prediction. Say it's a demand forecast or some sort of inventory level. So you're producing a number, and then you're feeding that number into an optimization model. And that's what we're going to see a little bit later. And then the third way is something that is kind of exciting, something that Gurobi has put a little bit of effort into sort of making it easier for people to do stuff like this. What you see all the way on the right and that's to actually embed a machine learning model inside an optimization model. So let's say that you have a machine learning model that relates the price of an item to the demand. Obviously, if you increase the price, the demand will go down. If you decrease the price, the demand could go up. And that's but there's a lot of other factors that could be important to consider when building a model that would forecast something that says, hey, if I set this price and I have all these other conditions, what's my expected demand? That could be a very complicated relationship, and something like a linear regression model may not be the best fit. So you may decide to use a more complex model, something like an XGBoost or anything, anything under the sun that you have available to you as a data scientist. Well, then if you want to build an optimization model around that to help you sort of maybe then have a more efficient supply chain holistically, then Gurobi has recently released an open source package that can help you embed that model into your broader optimization model and make that a pretty seamless transition. So I'm going to talk about that more if time permits at the end. But again, these are sort of three ways that machine learning and optimization work together. So if you're asking, okay, well then I kind of know a little bit more about what optimization is. I understand who uses it, and I can sort of now see where I've maybe come across some optimization problems before that, and I didn't know that they were there. How do I implement an optimization model? Well, from Gurobi, from our perspective, we have a lot of lightweight APIs. Python is by far our most popular. I think something along like 90% of newer folks are using Gurobi or using Python. But we also work with a bunch of other programming languages. So any other avid R users like me, we have an option there. But because Python is our most popular API, we have a lot of additional Python packages. Again, some of these open source ones that we mentioned, I sort of have listed on the right of that top right box. I'll be diving into maybe some of these a little bit later. But again, we have a very robust, very awesome Python API. So if you're, again, that's where most data scientists tend to work as well. So that's why, we decided to make that a pretty easy way to get going in optimization modeling. But we also have a lot of flexibility in the cloud as well. So a lot of containers, and we also work well with in containerized environments, and we also have our own sort of way of doing cloud-based optimization as well. And again, I may get into this a little bit later, but it's there, and it's super easy to get going with a lot of this stuff as well. And then if you want to use an open source modeling package as well, something like Pulp or Pyomo, those are very popular ways to do mathematical optimization in Python. You can call Gurobi from there, but you won't have access to all the features, and it's not something that we officially support, but it is something that you can use if you'd like to. The last thing that I want to talk about before I get handed over to Yash is comparing some heuristics to mathematical optimization, because a lot of the most common way to sort of solve a decision problem without really getting into optimization is to say, okay, well, let's come up with some pretty smart way to help us actually take our forecasts or whatever it is and act on them. So let's come up with something that's smart for our business, for our project. So if you apply that, that's essentially applying a heuristic, and I want to compare that a little bit to mathematical optimization. So the development time of a heuristic is typically, it's very fast. Although if you want to get complex, then it can add some time. It can become pretty complicated. So it's sort of as complicated as you want to make it. It could be something that, if I use this term a lot in the consulting world when I was there, quick and dirty, or it can be very robust for your particular problem. Mathematical optimization, it does require sort of in-depth knowledge of the problem, and it is a detailed model of a complex system. So there is a pretty significant time investment that you need to make in order to get this going. But as we go down this list, we'll sort of see that it could be worth it for you and your problem. So the time that it takes to get to a solution. Okay, how long does it take me to get something that I could use? Oops. I made a typo here. Sorry about that, everybody. For heuristics, time to get solution, again, very fast, can be, and that's the whole reason why you do it. On the right, it depends on the size and the structure of the problem. Can be done. You can solve an optimization problem in seconds, sometimes even half a second or even lower than that. But sometimes it can take a long time to solve some of these problems because it all depends on the size of the problem and it depends on the structure of the problem. Which, if you want to understand what that means by the structure, it's a little bit more complicated. But we have plenty of resources and webinars and things like that to help you there. The quality of the solution. A heuristic provides a good solution, but there's no guarantee of is it actually feasible for you, can actually do it, or is it, how far is it from a possible optimal solution? Those are all unknowns. A mathematical optimization solution is guaranteed to be both feasible and globally optimal. So if you get a solution out there that pops out, there's nothing better out there for you in terms of a solution. So that's something that really helps instill confidence in decision making. And then model adaptability. This can range from very little work, but sometimes if a problem changes in a certain way or large enough, you have to start all over and rework your heuristic model. Updating a mathematical optimization problem is typically requires adding just a couple of constraints maybe, or just some variables. You already have your complex system modeled, so it's typically straightforward and easy to add things that sort of pop up as new constraints or new ways of making decisions. So that's all I have. I'm over to you, Yash.
Thanks everyone for joining. Good morning, good afternoon, good evening, wherever you are. I'm really excited about the opportunity to talk to you about Databricks and Gurobi, two tools I'm really excited about. Before I dive into the meat of the matter, let me briefly introduce the company I work for, Aimpoint Digital. So very briefly, we are a data analytics and data science consulting company. We are a boutique firm. We were formed about 6 years ago by two founders, and today we are about 80 plus consultants. And the reason for this phenomenal growth is primarily the level of expertise we bring in. We have a fabulous team with experts in a lot of diverse areas, and a lot of our team, the majority of them have advanced degrees, including PhDs. And combining that expertise with making sure we always put our clients first has allowed us to really carve a niche in several areas. Primarily, some of them are healthcare, biopharma, manufacturing, and retail and CPG, but we also work in other areas as well. And the fact that our clients like to work with us is very obvious from the fact that most of our clients come back for multiple repeat projects. We are organized into 4 different groups, and although we work very closely with each other, obviously, the foundation or the bedrock group is the strategy group, and it really sets the tone or the vision for your firm. Wherever you are with respect to the maturity when it comes to analytics and data science, we are there to help you form a strategy, form a vision, develop a plan, and help you execute on it. And the execution comes through the other 3 practices. So the data analytics practice is responsible for process automation, dashboarding, business intelligence type applications. The data science team helps deliver advanced machine learning and optimization use cases. I'm obviously a part of the data science groups. I'm a principal data scientist here. And both of these rely on the the foundation provided by our data engineering and infrastructure practice, which makes sure that the data infrastructure is set up with the modern tools and tech stacks to service these advanced analytics and data science use cases. So the advantage that we have is that we work end to end with our clients, and in order to do that successfully, we partner with a lot of state-of-the-art tools in the various domains. Obviously, Databricks and Gurobi are two of them. And specifically, we are a premier Gurobi partner, and we are also certified to deliver Compass trainings. So if you have any training, enablement, or deployment needs with Gurobi, we can help you on both. With that, I'll switch a little bit to talking about why should we care about Databricks. And from the audience poll, it seemed like about half of the audience was already a Gurobi user, and the other quarter had familiarity with Databricks. But there's a quarter of the audience today that is not used Gurobi or Databricks. And my hope is by the end of this webinar, you're all excited to use both tools, Databricks and Gurobi, because both offer phenomenal value. Jerry has already covered some of the nuances of ML and AI, so I won't spend too much time on this slide. And of course, the point here is not to draw any kind of dichotomy in some sense. Optimization science and data science are not necessarily two distinct or completely distinct tools, but they are two of the important tools that are play a big role in providing practical solutions to a lot of use cases. So whether you use one or both, depending on your projects, or whether you're a business manager who works with both, hopefully you can recognize and identify with some of the things mentioned on the slide. And again, my goal is to help you show today how Databricks and Gurobi essentially enable both for your projects. So what is so special about Databricks? For those who may have not have heard of Databricks, it actually has a very, very rich history in terms of innovation and technical advancement. So the founders were the original creators of Apache Spark, Delta Lake, and the MLflow packages. They open sourced them. They're all available to us for use freely. And these founders then on top built a pioneering Lakehouse platform. That platform is Databricks, which is what I'm going to demo very shortly. And because of this rich history of innovation, Databricks is, you can tell it's made by engineers, it's designed in a very technically solid manner. And the advantage of that is it provides a single uniform architecture to support all kinds of workloads. So historically, people have thrown around terms like data warehouses and data lakes, and each have their own pros and cons. But the Databricks Lakehouse platform is the first that can service all use cases with structured data, unstructured data, with files, with images in a uniform environment. And with that, you're now providing a single experience or a single place where all personas in your team can collaborate, and you can service all kinds of applications, whether those are data engineering based, data streaming based, or data science based. Those of you who are already familiar with Databricks may have seen some version of this figure. It's adapted from something on the Databricks website. What we want to argue today is that the Databricks Lakehouse platform fundamentally supports mathematical optimization in just a seamless fashion. Jerry has already covered a couple of situations or cases where, for example, a lot of machine learning algorithms rely on optimization under the hood. If you think of stochastic gradient, that's an optimization algorithm. Similarly, a lot of optimization applications will rely on inputs that come from the predictions of a machine learning model. So in that sense, they're very closely related, and hopefully I can show you all by the end of this webinar that they can both seamlessly coexist in Databricks as well. And there is a lot of value in it. So as a student, when I was learning optimization, I was primarily interested in formulating and solving my model as efficiently as possible. But in practice, you do need to think about where these models are going to be deployed, how they're going to be maintained, how they're going to be monitored. And in many cases, the ability to monitor and maintain a model long term is a lot more important in then solving the model most efficiently. So in that context, it's very important to think about where the optimization solution sits and how it's going to integrate with the rest of the tool stack. And in that context, Databricks offers a really nice way to make sure all your solutions are in one place. And finally, it's the next point is somewhat tricky because I well recognize that the modern data scientist is already wearing many hats. The modern data scientist is asked to be an expert in natural language processing, in computer vision, in generative AI, and what have you. But hopefully, you'll see that there is still value in also learning about mathematical optimization. If that's not a toolkit, that's not a tool already in your toolkit, or at the very least, be able to identify when a problem can benefit from mathematical optimization and be able to employ and find those resources accordingly. This talk is about Databricks and Gurobi, and I'm sure all of you are eager to see the platform itself. So I'm going to switch from the slides and go straight to Databricks. So the first thing to mention about Databricks is that it's a SaaS platform. It's a cloud-based platform. All the work you do is typically done through a browser or perhaps through API calls. And that by itself is already an advantage because those of you who may have been familiar with the pain that comes when developers are developing on their own laptops and emailing code or models to each other back and forth, this is already an advantage because everything is centralized. Those of you who have already solved this problem with using version control and things like Git and GitHub, Databricks integrates perfectly with all kinds of version control tools. So in that context, this is already an advantage. Everything lies in one place. This is my workspace when I log in. If you look at the panel on the left, you see a logical grouping of a few functions termed as SQL, data engineering, and machine learning. And this is just a quick nod to the fact that the features that Databricks offers support all of these different personas and personalities. So whether it's writing SQL queries and doing some analysis, dashboarding that a typical data analyst might do, or whether it's building data pipelines and setting up data ingestion processes, which a data engineer might do, or whether it's ML, AutoML, or advanced machine learning features that Databricks offers, they're all available in one spot for everyone, which is fabulous. The other thing that hopefully you all have noticed is the word notebook. And of course, this is the notebook that I'm planning to show you all today. So let's just jump right into it. Before I go any further, I do have to acknowledge some of my colleagues do think that the light theme is an abomination because light attracts bugs. For those of you who feel the same way, just want to point out that you do have the option of using a dark theme as well. For today, I'm going to stick to the light theme, so please forgive me. Jokes apart, hopefully the first thing you notice is that this is a notebook. This is just like a Jupyter notebook experience. So if you are used to doing any kind of development with Jupyter on your laptop or anywhere else, the development experience is more or less the same in Databricks. The only difference you'll see is that instead of a kernel, I have a connection made to a Spark cluster. That's where all my code will actually execute. And that is already an important thing to call out. Whenever we mention a new platform or a new tool, there is often fear about how long it might take to onboard onto it or how long it might take to actually learn the platform. In the case of Databricks, if you're already used to working with notebooks, you can continue developing just the same. Sherry already talked about what kind of problems mathematical optimization might solve. So I'll skip some of this textual description, but just to call out that anytime you're trying to make a decision on what I should do next or where I should do it or when I should do it, you might be able to leverage mathematical optimization. And of course, we've already discussed how machine learning and mathematical optimization are closely related. To make the example, to make this demo more interesting, we have adapted it from a use case we delivered for one of our clients. Our client is a provider of logistical services to various manufacturing firms. these manufacturing firms will typically have their manufacturing operations somewhere in Asia and their retail markets in the US. So obviously there's a lot of logistics involved where you need to move stuff from the factory to some kind of a warehouse and a sorting and dispatch center, from where the material is then further trucked to a port and brought to North America on ships. And from there on, it is transported to destination warehouses. So for the purpose of this case study, our focus was how can we make this shipping as efficient as possible? And the thing to consider there was, when the customer of our client makes these orders, they book these orders weeks in advance, and these orders are then received maybe 2 weeks, 3 weeks, 4 weeks after. And what our client needs to do is to figure out how to pack these orders as efficiently as possible in containers, so we're using the least number of containers possible. So in some sense, it's a giant game of Tetris that we are trying to play. Let's look very briefly at the data itself. So the data is here, and let me scroll just a bit down so I can go to the first column in the data set. Yeah, and if you all have noticed, you can write Python code in this notebook just as you would in any other notebook. In this case, I'm using the Spark library and just executing SQL code directly. Because this data is redacted and anonymized, that's why you see things such as customer:0 or :6, just trying to anonymize any information. There is a style description column that describes what are the kinds of things we're trying to ship. And you note that these are typically things like pants or jackets or polos or what have you. We have information on the origin and the number of units that were booked. And we also have information on what the customer said was the amount of weight that they were planning to ship, and as opposed to what was the actual weight received when the client did pick up the shipment. And normally you would expect this to be the same, which is what you see in the example here. These columns match. But when we try to analyze the data in more detail, what we found out that these columns don't accurately match always. So I've hidden the Spark, the code that was used to do this analysis, just to keep the notebook a little easier to read. But all we're trying to do is to plot or count the difference between the booked weight and the received weight and run some statistics on it. And what we find is that there is almost 12% of rows in the historical data set that have a mismatch. Now, that is problematic. And it's also problematic because this mismatch is not small. It can be quite large. The average is about 125 kilos. Of course, it's heavily impacted by certain values that are clearly extreme outliers. And my cat is here and wants to say hi and join our webinar. Let me put her away. Sorry about that. So clearly, not knowing the exact weight, I think somebody wants to see the code, so I'm happy to share it for just a minute, but hopefully this makes sense to you. But this is clearly a problem because if we don't know the weight that we're going to ship, it's going to be problematic to decide how we're going to pack the containers together. So in that context, before we can even decide how the orders are to be packed in different containers, we first need a way to estimate better what the weight or the predicted weight for each of the orders is. And for that context, I'm just going to switch very briefly to a different screen. And this view is available in Databricks from the workflows view. And this is a workflow that is configured within Databricks. So there are a few tasks in this workflow. We start by ingesting historical data. We build a predictive model and schedule some predictions. And further, we use those predictions with the current order data as well as the container availability data to build an optimization model. So in some context, hopefully this describes all the processes that are fairly common in any optimization application. You may have to do some data wrangling, data ingestion. There may often be a predictive or machine learning component involved. And finally, there may be an optimization or a decision-making component involved. And all of these can be seamlessly integrated within Databricks. So this workflow shows how you can also use Databricks as an orchestration platform and have all of these steps carried out here seamlessly. Moving back to the main notebook, I'm going to scroll down just a sec. So clearly we need a predictive model. The other nice thing about Databricks is that you can run a notebook from another notebook. So in that context, this helps in making sure the code is modularized and reasonably organized. But of course, the notebooks can also be linked from each other. So the notebook for machine learning modeling is here. Again, not the focus of the topic today, so I won't get into the details of how the machine learning model was built. But just maybe a thing to call out is that there are some PySpark imports here. So clearly, that's another advantage that Databricks brings is you can leverage Spark and process large amounts of data very efficiently. So the other piece to note also is that MLflow is deeply integrated within Databricks. So those of you who are already used to using MLflow for your MLOps kind of applications, you can use it seamlessly within Databricks. Again, the model that I built here is pretty, is somewhat preliminary, just some basic analysis. And just to see how well the model does, it would be good to compare it against a baseline. We have a baseline already in the sense that we know what the customer originally thought they were going to ship. So we have booked kgs as a baseline available. We'll just use that to compare the performance of our model against a baseline. The preliminary model we built has an RMSE of 1.31. The baseline RMSE is 2.9. So we're going to say this is good. We're already doing twice as better as the baseline. And we're going to use predictions of this model to estimate a better value for the received weight. We go ahead and apply the model to new data sets or the orders that actually need to be planned in the future. So the same thing, we have customer, order number, the origin and the destination between which stuff needs to be shipped, and the prediction for the received weight. Obviously, when we are doing order planning, we need to plan for origin destination pairs separately. So in some sense, this can be parallelized and solved across distinct origin destination pairs. So next, to go on to order planning. Now that, let's just say we have value for the orders and we have values for weights predicted, but they're better than perhaps what the booked values were. How should we go about doing the order planning? Cherry already talked about heuristics versus mathematical optimization. And of course, mathematical optimization, when succeeds, is guaranteed to give you the true optimal value. But it's still not a bad idea to try a heuristic approach. At the very least, it gives you a baseline that you can compare against. And it can also helps you show the value that Gurobi brings on top of a heuristic solution, so you can convince your business managers and keep them happy. Again, to keep the notebook somewhat concise, the approach is implemented in a different notebook, and we just call it here. But let me briefly describe what the greedy assignment approach is. So if we were to try and think of a greedy assignment heuristic or a heuristic to solve this problem, the goal would be to try and pack things as efficiently as possible. So in that context, let's just say we have 7 orders that we're trying to pack, and we have 2 containers available, and we know the order, the weight of each of these orders, and the available capacity. A quick heuristic would be to first sort these orders in descending order, and then we just start packing them together in a greedy fashion. The first order was 7 pounds. It clearly fit in the first container, so we just put it there. The second order was 5 pounds. The 5 pound order and the 7-pound order would not have fit in the first container. Clearly, there wasn't enough capacity. So we put the 5-pound order in the second container. We can proceed in the same fashion, and we can see that we packed these containers pretty well. There's only a little available capacity left in both, but we're not able to pack all the orders efficiently. And we are left behind with one order, which means we need 3 containers in this example. So let's just look at the implementation real quick. And again, in the interest of time, I'm not going to go through the entire code, but it is implemented here. Maybe I'll just go quickly to the assignment function, and hopefully this makes it simple to see how the assignment was implemented. So the heuristic is implemented simply by we take all orders, we sort them based on weight, and we simply assign them. We try to assign them in a container, and if the container is able to accept this order, that's great. If it is not able to accept this order, we just continue looping and go to the next container. And hopefully we have enough containers to assign the orders. Otherwise, we throw an exception. So just going back to the main notebook and trying to get a sense of how well does this heuristic do. Scrolling down a little further, we'll just quickly plot the total number of containers used and the average fill rate. And in this example, for a small subset, again, for purposes of a demo, we created a small anonymized subset of the data. And the total number of containers used was 312, and the loadability percentage was 76. So on average, every container is being loaded 76% of the time. So that's, or 76% of the total capacity that it has. So that's the result we get from the heuristic approach. Let's see what is the additional value that a mathematical optimization approach brings in. Again, to keep this succinct, there's a separate notebook that actually implements the optimization model, which is what we are going to call through a notebook command. Let me switch to the other notebook, and we can just talk about it briefly. So the first thing I want to talk about using optimization with Databricks, or specifically using Gurobi with Databricks, is that it is extremely straightforward or easy to implement. So the first thing all I've noticed is that this is Python code, and you can directly run Python code in Databricks. So that means all you really need to do is to configure your license and pass it to the Gurobi environment in the right way. And once your license file is configured, you can write your Gurobi models just as you would anywhere else. So in that context, what I have done here is I've made use of the Databricks feature or functionality called secrets, because obviously my license key and my license secret are private, and I don't want to leak them to anyone. So I have set them as a Databricks secret. You can think of it as an environment variable. And once these parameters are available in the environment, you can simply retrieve the secrets and set your Gurobi environment by passing those parameters as an option. And you can see from the output here that Gurobi Pi has clearly recognized that the license is valid, it's registered to me. And you can also see how Databricks is being very protective, and it's redacting the secret even if Gurobi doesn't think the secret is worthy of redaction. So in that sense, all I had to do was set a couple of environment variables that had my license information and call the Gurobi environment command appropriately, and I'm good. My license is recognized, and now I can go ahead and formulate my optimization model. The key value, and Jerry alluded to this earlier when he said that it's a good idea to write the mathematical model, and I agree that the main value that an optimization scientist or an OR scientist brings is actually converting the business case into a format that Gurobi can understand. And the format that Gurobi can understand is typically a MIP model or an MIQP model, but let's not go into that right now. And that's how we basically earn our keep. We understand the business as properly as we can, and then we convert it to a mathematical model with the constraints and the objectives correctly identified. Once these are identified, the next major thing is where Gurobi shines, or Gurobi brings its value. This is again implemented in Python, and hopefully some of you can recognize the functional calls like model.addVars, which hopefully looks very familiar. The idea is once this is done, this is where Gurobi shines, or this is where the value of Gurobi comes in. In theory, you could enumerate all possibilities exhaustively and find the best solution. That's pretty straightforward to implement in this case. The problem is that those possibilities are too large, and that would be too time consuming. Where Gurobi really shines is the ability to find the true optimal solution without enumerating all possibilities. Just to see what that looks like on this sample data set. Again, we just try to check the quality of the results in the same way. In this case, the total number of containers used is 299, and the loadability percentage is 80. The number of containers used have now been reduced by about 4.5%. And that may not seem like much, but if you recall, this 4.5% is obtained with no additional capital investment. Being able to achieve this kind of improvement over a heuristic, all with a little bit of code and being able to access Gurobi is phenomenal. And when you think of the scale, when you think of the fact that this was a very small example, when you think of the fact that the orders are allocated across time, across multiple origin ship pairs, for example, this amount can scale very massively. That brings me to the end of my demo, and I do have a couple of slides just to end with before I hand it back to Cherry. So just a couple of takeaways, and if you identify yourself as a data scientist or primarily using data science and not necessarily as prone to using mathematical optimization, I would encourage you all to give it a shot, to learn more about when optimization can be applicable. Obviously, there are no free lunches. Mathematical optimization cannot solve all problems, but the problems that it can solve, it solves really, really well. And similarly, just a couple of takeaways. If you are a user of Gurobi and optimization, it's still, and I consider myself in that category. To be honest, I prefer writing MIP models and solving them, and I love using Gurobi. But I do think it still behooves us to keep up to date with all the modern tools and platforms and be able to integrate our solutions, because that's really how we can make sure our models continue to drive long-term value. And from that context, learning Databricks, keeping up with Databricks, and being able to implement your model in Databricks is an absolute no-brainer. With that, I'm at the end of my portion. I'll stop sharing and give the control back to Jerry.
We have about 10 minutes left. We want to leave some time to answer questions. I'm going to skip the section on those couple important points about using Gurobi in Databricks, but it'll be in the slides that you'll get when we send them out. So that information will be there. Because I do want to hit on some of the things, some of the resources that we have at Gurobi that will that can help you on your optimization journey if you are new to that space. And Yash did a great job of highlighting how, a heuristic can be a great way to get started, but in some complex problems that mathematical optimization can give you that extra little bit, and sometimes an extra lot of bit to increase whatever, your efficiency or your profitability and things like that. So I want to just hit on a few of the key resources that Gurobi has developed over the last, couple of years that I've been here, but and definitely before then a little bit too, to help you sort of figure things out and how to go, well, what's your next step in optimization. So one of the key things that we have is a really awesome set of notebook examples across lots of different industries, lots of different problem types. But over the last couple of years, we've been creating specific examples that are sort of catered to the data science crowd. So things like one of my favorite examples is avocado pricing, and with that example, we sort of show how to use one of the open source packages that I was talking about that helps you embed a machine learning model into a broader optimization model. But we also have a bunch of other cool things of using linear programming for possible plagiarism and fantasy basketball as well. So we have a lot of cool examples that help you sort of understand how machine learning and optimization can work together. We have a ton of webinars. You're in one. Thank you. But a lot of different, I've been doing the webinars on the notebooks that I was just talking about. But we have webinars and other videos and tutorials and things like that. A lot of sort of video content that can help you understand optimization from a broader context, or if there's things you want to drill down into and understand more specific features or things like that, then we have those types of webinars and videos and things for you as well. One thing that I want to mention is the burrito optimization game. It's a game that we at Gurobi recently put together. Shout out to a whole bunch of people who put that together, including Allison, who's one of our tech experts today, who's going to help answer questions. But it's a super awesome and easy game, seemingly easy game, that helps you understand the complexity of optimization and why it's needed. So it's all about placing your burrito vendor trucks across a sort of fictitious city in order to feed people for lunch. And it seems like it's a very easy problem. It's like, yeah, it should be able to do very well just by eyeing some things up and satisfy a lot of customers. But what you learn very quickly is that the combinatorial nature of this type of problem is very, very difficult. So it's a great way to understand the complexity, like I said, and it's a great way to communicate the advantages of optimization. And then lastly, the open source tools that I've been alluding to. These are Gurobi sponsored Python packages that really make integrating machine learning and optimization easier than ever. So we have pandas functionality from Gurobi PyPandas, Gurobi machine learning, which is the package that lets you do that embedding that I've been talking about. And then one I haven't mentioned so far is called Gurobi OptiMods, which are pre-built optimization models that you can sort of use right out of the box to get some goodness out of and help you understand how optimization can be used for certain problems. And then if you want to learn more, the code is there to understand how the modeling works, and then you can sort of take it as your own. So the next question may be, okay, that sounds like a lot of cool stuff. How do I get to it? One way to just go to gurobi.com and then hover over solutions, and then you'll see this role for data scientists. Click on that, and that'll take you to a great way to access all of this stuff. But if you just sort of hop along our website as well, all over the place, you'll find all these resources and more. So with that, I think we are, at the Q&A time. So let's go and rapid fire some questions.
Great. Thanks for the presentation. There's definitely a lot of kudos showing up in the chat. Maybe to start off the question from the audience, can you provide any tips on how to manage Gurobi licenses in Databricks? Yes, I suspect you have some experience here.
Yeah, I was actually hoping to tag in Zed here. Zed may be able to give 4 complete answers, if that's okay. Otherwise, I can take a stab.
Okay, I can answer this one if that's what you want. So there's several ways to handle licenses in Databricks. You can actually have the most recommended license is a WS license, and you can attach the license as a file to the cluster. I can send the detailed instructions maybe to you directly if you are interested. And you can do it as embedding the license information in the code, exactly like Yash did in today's presentation. So those, you can say like you have those 2 methods in order to have the license information ready for Gurobi.
Great. All right. So similar lines on recommendations. Do you have any recommendations on the compute size for Databricks, for a Databricks cluster to run Gurobi optimization?
That's a good question, and probably not going to like my answer when I say it depends. It depends on the model you're trying to solve. It depends on how big it is, and it depends on how fast you need your answer. So maybe you just need to do a little bit of experimentation. And I know Gurobi offers fantastic resources for tuning as well. So maybe you can get some help from the Gurobi expert team in that context. Hopefully, Alison, you don't mind me adding more work to your plate.
Oh no, please do. We love tuning tickets. Okay. I'll go with the next question. So we actually had a question around redundant constraints and optimization. Really, are there any tools that you guys use to identify or maybe address redundant constraints in your optimization problems, particularly when there's, a number of decision variables and constraints? We did have Zed put in a text answer discussing how Gurobi's pre-solve does seek to eliminate redundant constraints that it identifies, but I'm curious to know, do either of you have tools or strategies to either avoid or identify redundant constraints?
Yashir, I'll yield to you first.
Okay. I think the pre-solve is often my first go-to as well. And the way I like to think of it is Gurobi's pre-solve is already pretty awesome and can get rid of a lot of redundant constraints by itself. But if I see in the Gurobi logs that a lot of constraints are being removed or a lot of variables are being removed, that actually tells me something is wrong in my model. Or maybe nothing is wrong, but I can probably formulate my model more efficiently. So then I will probably go back. And one thing that helps in that context is if you write your model neatly in a modularized fashion. So that allows you to do a quick experimentation and turn things on and off and see what the pre-solve results look like. And that's typically the kind of experiment I would do. Most importantly, it's often always a good idea to write your model on paper first. You learn a lot that way. It's also a good idea to explicitly write out your model constraint by constraint on a small example. That also teaches you a lot about the model you're solving and hopefully gives you insights already into what is redundant and what's not. Cherry, anything else you do on top of these things?
I was gonna say like it works for me to write things like writing. The more things I write out, and this was going back to the point earlier of it's always great to write your model algebraically and everything. It's that's what I think is a you want to get to the answer. So if you want to get to the answer, you got to get to the code, so people, sort of kind of jump into that maybe a little too quickly, but optimization modeling is an art. And with that, it's definitely great to take the time to do it very thoroughly.
I just want to echo that point again, because it's super important. Please try to write your model on paper first before jumping directly into code. It will often save you a lot of headaches down the line. There's another point to it as well. Of course, when you look at the Gurobi results at an optimal solution, you can see which constraints are active and which are not active based on the dual values. That can also be a helpful tool. It just has to be treated with a little more caution because what is redundant in one scenario may not be redundant in another scenario for your model. So just be careful with it.
We had two questions from the audience. Also, they are asking, can Gurobi support multi Databricks clusters? Like, can you run it on a Spark cluster? Is Gurobi PyCode executed in a distributed fashion across the cluster? And I don't know if Jerry, also, if you want to pick up this one.
I mean, since we did skip over some of that stuff and I got a lot of that information from you, Zed, if you want to make a quick comment on that, since we're running out of time, I'd appreciate it.
And so Gurobi does not support multi-node Databricks cluster. If you want to run Gurobi with Databricks, we recommend to go for a single node one. Gurobi does support distributed optimization, but we have our own add-on to do distributed optimization. And for several reasons, I can go through them, but maybe not. We don't have the time to do it today. Usually, mathematical optimization parallelizes really well with additional cores. Doing it through distributed matter may actually cause an overhead. And that's, I hope I answered your question regarding the distributed fashion across the clusters.
You summarized what I would do much more concisely. I tend to blab.
Thank you. Should we pick more questions, or I don't know about time?
Yeah, I think we're just about out of time. And I think we have some good chat. Thanking everyone for the great webinar. This was really informative. I think we have some folks that might be converts to using Databricks and Gurobi together. So thanks for doing this. And, you know, Yash, thanks for the guest appearance of your cat. That was also well loved.
Wonderful. Yes, very, very good stuff. Thanks, Allison. And that's all the time we have for today. And thank you again to Jerry, Yash, Zed, and Allison. Please do take a minute to participate in our survey. We would really appreciate your feedback, and let us know if you think there's anything we can improve on, if you have an optimization project in the near term, or have general questions or comments. Thanks again, and we hope to see you in our next webinar. Thank you.